Hello, everybody. Thank you for joining us today. We are here with Steve Upton from Can-Am Integrations. Can-Am has been a plastics equipment rep in the upper Midwest for over 30 years, representing lines such as Nisi, Yushan, Dry Air, Friegel, including Emitted Energy. They also have a facility in Menominee, Wisconsin, where they operate both Can-Am Integrations and Schmidt prototypes. Can-Am Integration designs and builds custom automation systems and has been a Fanuc Robox integrator for over 22 years. Schmidt Prototypes provides prototype and low volume solutions, which include services from 3D printing, urethane casting, machining, injection tool building, injection molding, finishing, and assembly. Please contact them if you have any interest or if you have any questions about infrared technology, please feel free to ask them. Thank you, Steve, for joining us today. You're also sitting here with Roy Ray, our Vice President over at Emitted Energy, and Chris Lemons, our National Sales Manager.
All right, thank you, Ricky. And Chris, where are you joining us from?
Oh, Chris, I believe you're muted. You might have to unmute yourself.
Here I am. Sorry about that, guys. Yeah, so I'm at the AmCon trade show in awesome Cincinnati, Ohio. So thank you all for joining who is on the call here. And we're going to do this webinar a little bit different. We've tried a few approaches with our webinars to engage the audience, but this time we thought we're going to do basically open it up. This webinar is to cover thermal imaging in the injection molding process. But what we're going to do for this webinar is just basically open it up for questions. So if anybody at any time throughout this 30-minute webinar would like to ask a question related to thermal imaging and injection molding, please chat those in the chat room and Ricky will read those off and we'll answer them live on the air. So with that said, Ricky, I'll turn it back over to you.
Okay, thank you, Chris. So while we're just waiting for a couple of questions to come in here, I would just ask you or Roy, if you wanted to kind of give a quick overview of the technology and the solution without going too deep, just a basic principles.
Okay.
Sure.
Yeah. Go ahead. No, go ahead.
I was going to let Roy fill that question and then I'll answer any injection mold specific questions.
Okay. Well, look, you guys, infrared technology is a non-contact machine vision, thermal machine vision approach, and it's becoming more and more popular in automation equipment in terms from thermoforming, blow molding, plastic joining, and certainly in injection molding. And injection molding is very, very important to utilize non-contact data driven approach to understand if you are producing parts consistently and without defect, right? So we've really spent a lot of time looking at how infrared thermal technology can present to us the information we need to make decisions, and spend a lot of time on injection molding equipment, certainly partnering with like Steve from Can-Am and others, master injection molders throughout the country to really understand what are the pitfalls, what are the challenges that are commonly found in manufacturing facilities, and how we can adopt thermal imaging technology to help us understand and find root problem analysis at the end of the day. So utilizing this non-contact approach really provides us a lot of data that beforehand we can't get. We cannot get them through the visual spectrum, so standard cameras. We cannot get the same type of data through pyrometers or thermocouples. We can't get the same type of data even inclusively from RJG. So we'll kind of address some of these. I'm sure fielded through some questions, but certainly we can kind of deep dive in some of this. But you know, looking at how we can add a new piece of cutting edge technology to help us answer and solve today's common problems really gives us a competitive advantage in the marketplace with our customers and certainly with return on investment, where you're saving money on a day-to-day basis utilizing this type of technology. So we're very excited to be able to introduce this technology and to really kind of showcase what this can do. I will put this out there. If anyone on the call here would like for demonstrations at facilities and to really kind of deep dive in specific areas that you have concerns at your facility, definitely reach out to Steve at Can-Am or even Chris to get something scheduled, right? Because I'm confident you're going to be impressed with this technology can deliver.
Awesome. Well, thank you, Roy. So with that, you touched on this just a little bit, but can you please go a little bit deeper and compare your TPMS to a standard vision system?
Certainly. I mean, a standard vision system utilizes the visual spectrum and presents us a camera like what we're seeing today. What that does is give you a visual image of what's happening, but what you can't see is you can't see heat, right? We're not reptiles. We need to utilize seeing anomalies and changes and deficiencies in thermal contrast into a part to really understand what's going on. So a visual system is merely like taking a picture, and it doesn't really provide you a tremendous amount of information. Whereas a thermal camera, which reads surface temperatures in parts, we can correlate temperature values to known defects. So if you have a hot spot in a particular area, that can tell us something. If you have a colder spot in a particular area, that can tell us something different. And certainly temperature change over time, what's happening with the part as it is completely formed and starts cooling. So there's a number of different areas that we can use thermal imaging as a tool to help us answer some tough questions.
Okay, awesome. And so another question came in from Tom here. From a 30,000-foot view, what are the different opportunities for thermal imaging regarding molds, parts, runners, equipment? So kind of a comprehensive look at the injection molding process.
Chris, you want this one?
Ricky, yes, I had trouble hearing that. Can you repeat that question, please?
So yeah, from a 30,000-foot view, what are the different opportunities for thermal imaging regarding molds, parts, runners, and equipment? So kind of a comprehensive view of the injection molding process.
Gotcha. Well, I know injection molding is, it's a closed system, right? So the tool closes, it's very controlled. So what we like to do from a thermal imaging standpoint is take an image right before that robot grabs the part and pulls it out, or even if it's more of a primitive operation where an operator reaches in and pulls it out. So by setting those regions of interest, we can see that. So how does that compare? Well, really, Roy kind of put it very well. I felt like, like there's visual systems, there's RJG, there's thermocouples, there's all kinds of great sensors out there to help you with your injection mold process. And we don't look at ourselves as competition to any of those. We're completely outside of that realm. But in the end of the day, the best way to say it is if you don't have thermal imaging, there is data out there that you are not getting. And we consider ourselves a data company, a company that provides data. And if you don't have a thermal camera on your injection mold process, there is data that you are lacking. And we all know the more data you have, the more knowledge you have. And the more knowledge you have, the more power you have to beat your competition and run leaner and meaner and more efficient. That's what we're really passionate about, helping our injection mold friends out. I've talked to molders all over the country, and I've had people say, talk to people who build the tools, and they say, well, my tool's cut from a CNC machine, perfection. And we would not disagree with that. I've talked to other molders who say, I have a 2% scrap rate quoted and I'm running 1.8%, don't need your system. We wouldn't disagree with that. Congratulations, you're running under scrap, that's awesome. But any molder, if they're being honest, will tell you have ups and downs, peaks and valleys, right? Ambient temperature changes. And I'm sure when your material was certified at PPAP, I'm sure it's been perfect ever since, right? You never get moisture in your material. I can't tell you how many times I've walked by a molder and seen the Gaylord with the lid off, moisture's being introduced to the material. One of 1,000 things, and people on this call that are used to injection molding on a daily basis way smarter than me could answer a lot more of that. Everything about injection mold is heat in, heat out. It's all heat related, and a thermal camera can catch those anomalies and can capture that data to help you run leaner and meaner. I hope that answers that question.
Yeah, thanks, Chris. And then to add on to this, what we're specifically talking about, we want to look at the part. You can look at the part to find some of these anomalies that Chris is talking about. You can also look at the mold temperature, what kind of temperatures your mold is receiving if the cooling lines are actively cooling that mold to your desired temperatures, right? You can look at runners. I mean, there's, one of the things that we want, to look at is your startup, right? Your startup time and becoming efficient with that. When you do a tool change out. So, there are a lot of things and a lot of systems that can be put in place utilizing the camera technology, the thermal imaging technology to help us answer those difficult questions. All right, Ricky.
Awesome. Well, thank you, Chris and Roy. There was another question that came in. And so this one was from Diane as well. So does your TPMS control and or validate out of spec dimensions?
I can field this question. The short answer is yes, and the long answer is yes. So by using correlating data, yes, you can help control your dimensions, because again, how do you know that your part is dimensionally correct? Typically, it's heat related, and I'll let Steve chime in on this a little bit as well, just from an injection molding standpoint, not an IR standpoint. But correct me if I'm wrong, Steve. But if a part is running too hot, or it has an inaccurate shrink rate, it's going to have dimensional issues when you go to measure it. Is that correct?
That is correct. Yes. Yeah, that's the best way to say it. You're going to have a change in the part one way or the other. So if you can monitor with the thermal imaging and do 100% per shot, that's a huge advantage.
Yeah. So
rate,
yeah, for sure. Thank you, Steve. So a thermal camera doesn't have the capability per se to measure dimensional analysis. I can't tell you if your part's in spec or out of spec, but using the thermal data through the temperature and proper placement, precise placement of our regions of interest in areas that we are looking at and analyzing, you absolutely, using correlating data, can understand shot number one if you are going to be in spec or not. This can be done very simply by running, just call it 30 shots out of spec, 30 shots in spec. And you do this by running those, changing, running a DOE or changing the parameters, and then measuring the parts after they've cooled. We collect the picture at the onset, and then once those parts are measured, then you can validate those. You basically set your upper and lower threshold, right, with our system. So it's using correlating data. Not saying that we can measure a part, but because dimensional issues related to parts are so reliant upon proper temperature of products, you absolutely can do that. Shot number one, you can have the confidence that you don't have to let that part cool, and you're going to know you're in spec or out of spec. Furthermore, we can tie that signal in just as RJG does to your robot, and we'll send your robot a signal or your PLC a signal, and that robot can discard the part if you have short shot or any temperature anomalies that are going to cause dimensional issues, or any other tooling issues that you may have as well. Don't forget, just because we're looking at the part, we can place regions of interest on the tool as well. So if you're having manifold or waterline issues, we can certainly see that as well as the part. And each ROI is very customizable. You can name them accordingly. So if you're wanting to look at the gate, you can name it gate. If you're wanting to look at the product on the upper left-hand side, you can name it upper left of the product, or the lower right. And then if you're looking at the tool, you can name it manifold, or you can place certain areas of interest on that tool to not only look at the temperature readings and the data on the product, but also the tool, which is very, very important to injection molders. Again, it's data, guys, right? We're just giving you data.
Yeah, Chris, I'll add on to that. And too, so the folks on the line don't have to think that someone needs to be sitting there staring at these screens, looking at these images and looking at the analysis. What we typically do is we integrate this into the injection molding equipment in its entirety. So what we're doing is, if we throw something way out of fault, we want to notify an operator or a quality manager or a process engineer right away. And in fact, you even have the capability of stopping some of the pressing, so you can slow production down, you can run less scrap, you can even fault the machine on gross failure, so that you don't have to consistently waste product or scrap the product out until you can kind of look and see what's going on with the process and what's happening. So this is a fully integrated type of technology with the camera, while we still save and do a lot of data retention on the stuff. So you can look at trend analysis, you can look at a lot of your statistical process, trending analysis and charting. You also have images, but again, it is fully integrated in the system, because ideally working hand in hand with the injection molding equipment allows us a little bit of peace of mind that, hey, there's something watching the quality of my product, just like RJG.
Yeah, and I like what you said about the trend analysis. That's so true, because startup is important for molders. Going back to my story, you may run great on scrap. Your tool may be perfect, no issues, but everybody struggles with startup on certain presses. And I know I've worked with some great molders out there at SRG Global and other companies that, man, they've got some good talent out there. And it's amazing to me how on Monday, the thing starts right up and fires up. And Steve can attest to this. Tuesday, you run 60 pieces before you hit it. Why is that? I call it molding black magic, but regardless, we'll give you data for that to help you out to understand where you're failing in this process.
Awesome. Well, thank you for elaborating on that, you guys. So we have another question coming in here from Alex. So why do I need a TPMS when I already have sensors?
Yeah, that's a great question. That's a common question that I get quite often, and it's actually a really good question. So I'm going to answer it in reverse a little bit. Steve, can you tell us a little bit about when you're putting sensors into a tool, what are some of the challenges with getting those sensors in the proper areas that are important to the molder?
Yeah, whether it's a pressure sensor or temperature sensor, you're always trying to find the end of fill, sometimes at the gate as well. So what you're doing is I see a lot of people monitoring with the sensors. Some do the actual transfer on the process, but you're only doing it in certain points of the mold where I understand what you're saying and understanding. If I'm understanding correctly, you'll actually monitor the full molded parts, multiple cavities, whether it's one part to 16 parts, you'll monitor every one of them. Is that correct?
Yeah, that's correct. And that's kind of what we see, the sensors, I've been a program manager for a few years, so I understand, when you're awarded a job, the OEM, the studio wants a certain styling on their product. And unfortunately, a lot of times that styling challenges the engineers, the tooling engineers, to design that tool in a manner that's going to be conducive of running a good scrap rate. I mean, when you're a tier one or a supplier to an OEM, the challenge is giving them the part that they want with the scrap rate that you can meet. And then you also get the dubious honor of getting beat down by purchasing to get that scrap rate as low as possible, right? So we all want to be profitable. We all want to make money. So the challenge with that is I've been in many design reviews where sensors needed to be in a certain spot based on MFA's mold flow analysis. And they just couldn't be there due to a water line in the way or due to the geometry of the tool, or there's just not enough wall thickness in that area based on the tool design. So there's a lot of challenges with placing sensors. And to sum it up, our cameras, we typically use an A35 or an A65 camera for our injection mold solution. You're looking at if you go with the A65, you're looking at over 300,000 plus sensors on the tool, because a sensor is a pixel. We have over 300,600 pixels on our A65. So imagine that. Imagine having that many sensors. We can see 100% of the product. We can see 100% of the tool. And that's really what sets us apart and helps us to work hand in hand with the sensoring on the tool from a thermal imaging standpoint.
Yeah, and you can sell that as 100% inspection to them, depending on the process, and
every single part,
which is huge.
Every single part. And furthermore, if you imagine this, you have a customer. I've stood at many presses with my customer. They come in, You know, you go come in on the weekend, you clean the plant up, you hope that the employees don't embarrass you in front of the customer, and they're standing in front of your press. Imagine having the system running live there with the customer there, running an SPC trending analysis of your every single region of interest that you're monitoring. Maybe you have 15 of them on the screen. We have a 23-inch touch screen right there at the press. The customer can see it. It's very impressive for a customer to give that level of data and to let the customer know if part number 14 fails, then we can pull that thermal image and temperature data via CSV file to analyze that exact issue. So many times a customer calls, right? And if you're a supplier, you are guilty until proven innocent. How do you prove your innocence? Through data. And that's how we can do it. So you can pull that exact part that the customer's questioning, verify that it met the proper temperatures in the tool and the product at every single region of interest, print that thermal image and the temperature data, drop it into your quality document and send it back to them.
Okay, awesome. Thank you, Chris. And Steve there. So this next question that comes in, it's so they're starting to think about the process a little bit. So it sounds like we can take pictures, but can we take multiple pictures? For example, inside the tool and then post robot grab?
I'll field this one. Yeah, certainly. I mean, the system allows for multiple shots. And so let's say that we're not only looking at certain areas of the actual tool and validating that temperature with control limits established. Can't go over this, can't go over X temperature, can't go below Y temperature. We can also look at the part, of course, looking for all those common injection molding defects. But certainly, if we also want to look at a cool down method, let's say, looking at a part, capturing key areas, and then doing a second shot as the part is ejecting from the tool, the system certainly allows for that. And we trap that data, certainly look at that data and make that correlation decision whether or not we have a potential defect or something that at least needs to go in and have further quality inspection. So multiple shots within a single process is absolutely possible.
Thank you, Roy. So this next one that comes in from Henry is can I monitor tool temp and the part?
Yeah, it's just what I just answered. So you can monitor multiple different aspects. And what's really nice about utilizing a system like this, how a thermal camera works and how we're able to read surface temperatures is really based off an object's property to emit energy. And that camera picks up that radiation, that heat, and turns it into an actual temperature that we can understand. But each type of surface or a substrate has a different what's called an emissivity value, and it's basically its declaration of how much energy it can produce. So looking at a tool is going to have a different emissivity value than a plastic part. And so what we're able to do with our software is able to set specific emissivity readout values so that we're capturing a good temperature value and present that into a knowledgeable fashion. So we're able to set different levels for that.
Awesome, thank you, Roy. And this next question is coming in from Grant. He's asking, how are you keeping these cameras clean? We have thermal cameras inside an enclosure with a shutter, but they are still getting foggy. Do you have any good practices on this problem?
Yeah, I'll go and field that one as well. So absolutely. I mean, if you have cameras mounted in or around the machinery, of course they do get dirty. And shuttering systems is a method of attempting to keep the lens clean. What we would typically do is try to add an air knife to that as well. So you're constantly blowing clean shop air across the lens, and you don't let that plastic or any of those contaminants or debris get into the way of the lens, of the camera. So we do try to keep those ideas in mind, but you will have a PM schedule. Just like any other type of equipment, you're going to have to have someone wipe the lens down on a shift basis or a daily basis, and certainly keep a good PM practice going with them.
Okay, thank you, Roy. This next one's another one from Henry. what temperature ranges can we detect?
So we have a variety of temperature ranges that we can detect. It's actually a great question. Rory, I don't have all of the specs in front of me because I'm at a trade show, but I know for injection molding, we can go well above, unless you guys are molding at over 1,000 degrees Fahrenheit. I think we've got you covered. So the A65 is goes from negative, I believe, -4 to 1,022 degrees Fahrenheit. And the A35, Rory, what is the temperature for the A35? It's very similar.
Yeah, it's going to be similar, guys. I mean, at the end of the day, we tune the cameras. Part of our installation process really is looking at tuning the cameras to fit that bandwidth, that temperature bandwidth on the injection molding process. So they do go up to 1,022 degrees Fahrenheit, and of course down to -40 degrees Fahrenheit as well. So, but that's the temperature range. But what we do is we try to narrow that window. We're very specific about what temperature range we are evaluating and we are looking at. So our engineering staff does take that into consideration and monitors that temperature range so that we can get very crisp images, which then turns into better data with the camera. It's a very simple process, and it is all automated. So it's not a mechanical system. It is a digital programmable feature of the software.
Okay, thank you guys for explaining a little bit more about the temperature range within the cameras. And so Willie asks us, how does the technology interact with the tool? Can I add it into a current setup, or does it need, or can it be added to an exiting process?
I'm not really sure I understand. Was that an exiting process?
I believe so.
Yes.
Yeah, so the exit process.
So the systems, I hope I can answer.
Existing, sorry, an existing process.
Existing process, okay. So yes, it can, Henry, to answer your question. We are fully integratable. Most injection molders, at least in my experience, typically use Allen Bradley PLCs or Siemens, and we can certainly send the proper signals based on those PLCs to tie that into the process. Another integration point that may be important that wasn't asked yet is, I know injection molders are all about, I want to get that part shot and get it out and get that next shot going as quick as possible. So how long does it take to take a picture? When that tool opens and you have daylight, within milliseconds, sometimes robots, they want to come in, grab the part and take it out. We only need 0.2 seconds to take a picture. So I'm not going to add to your cycle time. That's not what we want to do. And we've been very successful in not adding to cycle time. So the second that mold opens, we're going to snap that picture, and then the robot can take the part, and we can be fully integrated, sending the signals to the PLC and or to the robot to be fully integrated to any press.
Yeah, that typically happens in just under 1 second.
Awesome, thank you guys. So this next question coming in from Alex is, does the system save the photo image and data separately, and how does this get exported?
Yeah, I'll answer this, and it looks like we're only going to have time. This will be the last question. It's 2:28 our time. So, guys, any other questions that you have, please send those to us in the chat room. Ricky will leave the chat room open for 15 minutes, and we'll answer those via email because we want to make sure we get to everybody. But yeah, the data is radiometric data. It's saved via CSV file. So the file system that we save it in can be easily extrapolated into an Excel document to run trending charts with the click of a button. We've made it as accessible as possible to collect that data. We actually had one issue with a customer. I won't say the customer name due to NDA, but they were actually producing a part for GM, and GM had a quality spill that they thought was their issue, and they called our customer, and our customer was able to pull the part that had ran 2 months prior via barcode. We can also pull it via timestamp as well if you don't have a barcoding system. And they were able to identify that it was not our customer's issue because of our thermal system. So that's a great case study that we like to share. So GM loves our stuff.
Awesome, thank you, Chris. And can you just elaborate a little bit on the photo image side of that as well?
Oh yeah, so sorry. Not only is the data stored, but also the thermal imaging is stored in that same file. So you can pull the thermal image and you can pull the data associated with that thermal image. to provide proper documentation to your customer. And Rory, can you just expound a little bit on how long or how many images can we store in our system?
Typically well over the life of the program, Chris. Typically we put 2 to 3 terabyte, we can put up to 2 to 3 terabyte drives in those systems to be able to host that. A lot of our customers actually end up on a regular cycle, kind of on a PM cycle, actually through FTP save those to a server dynamically. So they have a system, they'll go in there, grab that information and store for whatever data retention policy that they have in place with their customer. But we do allow for that file transfer and to save those images. So,
no, that's a great question. Well, we're going to have to wrap it up, but I did want to let everybody know we've had tremendous interest with our injection molding solution. We've had tremendous results. We've got some great case studies we'd love to share with you guys. And if you would like an application discovery for your specific application, we can do it in-house. We can do it due to COVID. If you have COVID rules still in place, we can do it virtually. That's not a problem as well. But let's get in there and start talking about your specific application and let us help you start to control and analyze your injection molding process better. A lot of injection molders are out there. We don't want you to be left behind. So a lot of injection molders are taking advantage of our system, and we hope that this helped answer any questions. But we are going to be hosting another webinar. We do these monthly. Based on the response for this one, we may have another like a part 2 of injection mold webinar to answer more specific questions. But I just want to take this time to thank Richard and Rory from Emitted and Steve Upton from Can-Am. Thank you guys. We really appreciate your support on this webinar. And yeah, like I said, we'll keep it open for 15 minutes to ask any questions. And then Richard will be sending out this recorded webinar to everybody who was not able to attend as well. So if you have any questions at that time, please feel free to reach out to Richard and we'll get those answered. Thank you, everybody, and I hope you have a great rest of your day.
Thank you, guys.
Thank you, Chris, for joining us. Steve as well. Thank you, guys.
Thanks,
Thank
guys.
you.
Bye-bye.
so who's on the list? I want to see that list. I mean, I recognize too many people is what I was saying.